All right, today we are going to be factoring special products. So your essential question is, how can you recognize and factor special products? So we've got a couple different kinds of examples here. We've got x squared minus 25, and then 4z squared minus 1. So if we look at these, you notice that on both of these are binomials, which means that there's only two parts. Okay. Normally, when we've been factoring so far, we factored trinomials, so there's three parts. So you had something that looked like x squared plus bx plus c. And remember, they had to multiply to be the last term, and they had to add to be the middle term. Well, with x squared minus 25, with that example, it's like there is no middle term. So it's almost like it has x squared minus 0x minus 25. So it's like they have to multiply to be 25, but then they have to add to be 0. Okay, so we have to figure out what numbers can multiply to be negative 25. So I have negative 25, and I want them to add to be 0. So I'm trying to multiply to be a negative number. So if I'm multiplying two numbers together and it equals a negative, then that means one number is negative and one number is positive. So what numbers can multiply to equal 25? Well, I've got 1 and 25, and I've got 5 and 5. So which ones, if you made one positive and one negative, would add up to equal 0? Well, it would be negative 5 and positive 5. So when I write my factors out, my factors would be x plus 5 and x minus 5. So if I check that, if I take x times x, I get x squared. And then x times negative 5 would be negative 5x. And then 5 times x would be positive 5x. So the negative 5x and the positive 5x are going to cancel each other out. And then I have 5 times negative 5, which gives me the negative 25. So when I multiply this, I get x squared minus 25. All right, now let's try the second example. So I've got 4z squared minus 1. Okay, well, this example is a little bit trickier because we have a 4z squared here. So when I have my factors, remember, I have to take the first number times the first number, and that has to equal 4z squared. So what number times itself equals 4? Well, I'm going to have 2 and 2, because 2 times 2 is 4, so it's going to be 2z and 2z. And then I have to come up with the other one. Well, I'm going to come up with numbers that multiply to be negative 1, and they have to add to be 0. So that would be negative 1 and positive 1. So you're asking yourself, what number times itself equals 4? 2z times 2z is 4z squared. And then what number times itself equals 1? So 1 times 1 is 1. But remember, we have to make one positive and one negative. That way our middle term cancels out. And you can check this by multiplying through. So I would get 2z for that one. And I did 2z times 2z would be 4z squared plus 2z. And then I do the middle one. So I would have minus 2z and then minus 1. So these will cancel out in the middle, and we'll just have 4z squared minus 1. So when you have a number here in the very front, you need to think what number times itself equals that number. Okay, so what happens is there's a pattern here. Okay, this is called a difference of two squares, because remember, we're multiplying a number by itself. And anytime you multiply a number by itself, that creates a squared number. So the difference of two squares, if your polynomial looks like this, it's a binomial, and both of these are perfect squares and they're subtracted, then your factors are going to be a plus b and a minus b. So for example, if I have x squared minus 9, this is a perfect square because I can take x times x to get x squared, and I can take 3 times 3 to get 9. So this is like x squared minus 3 squared. And so since those are your numbers, x and 3, then your factors are going to be x plus 3 and x minus 3. All right. So let's try a couple of examples and more factoring. Okay, well, if I try to multiply these together, what numbers multiply to be negative 36 and add to be 0? Well, remember, these are perfect squares. So what number times itself equals 36? Well, that would be 6. So our factors are going to be x plus 6 and x minus 6. Remember, they have to add to be a negative, or multiply to be a negative 36, so one has to be positive and one has to be negative. All right, this one's kind of backwards, but it's the same concept. So we have 100 minus m squared. So we're trying to think of what numbers multiply to be 100 and what numbers multiply to be m squared. Well, if we take the square root of 100, what number times itself equals 100? 10. So I'd have 10 and 10. And then what multiplies to be m squared? Well, that would be m times m. And remember, one has to be plus and one has to be minus, so that when we multiply them, we get a negative m squared. So you should start to see a pattern. It's the same numbers, but one's a plus and one's a minus in your factors. Okay, this one's a little trickier. 9n squared minus 16. Okay, what number multiplied by itself equals 9? That would be 3 times 3. So we're going to have 3n times 3n. And then what number multiplied by itself equals 16? Well, that would be 4 and 4. But remember, it's actually a negative 16, so this has to be 1 plus and 1 minus. Does it matter which one you write first, plus or minus? No, because when you're multiplying them, it doesn't matter the order. Okay, and then 16h squared minus 49. So this one, what number multiplied by itself equals 16? Well, that would be 4 and 4. So we have 4h times 4h gives us 16h squared. And then what number times itself equals 49? So it would be positive 7 and negative 7. All right, now we're back to trinomials. Okay, so remember, they have to multiply to be this number, so they have to multiply to be 16, and they have to add to equal 8. Okay, so let's think of the factors of 16. We've got 1 and 16, 2 and 8, 4 and 4. Well, which ones add to be 8? That would be 4 and 4. So really, we're going to have n plus 4 times n plus 4. Well, what's another way to write n plus 4 times n plus 4? How many n plus 4s do I have? I have 2. I'm multiplying it by itself, so I am squaring it. So another way to write that would be n plus 4 squared. Okay, you don't have to do that. You can keep it separated, but this is just another way to write it. Okay, let's think of this one. So this one we have factors of 9 that add to equal, this time it's a negative 6. So I have to have two numbers that multiply to be a positive but add to be a negative. So how is that possible? Well, if I multiply two positive numbers, I don't add to get a negative. But if I multiply two negative numbers, they multiply to be a negative or a positive and add to be a negative. So factors of 9, I have 1 and 9 and 3 and 3. So it looks like 3 and 3 are going to be our numbers, but remember they both have to be negative for this to work. So it's going to be x minus 3 times x minus 3. But another way to write that would be x minus 3 squared. So these ones are your perfect squared trinomials, because if you square this, it's going to end up with what we started with. All right, here are some more perfect square trinomials. Try these and see if you can come up with the answers. All right, so We have numbers that multiply to be 1 and add to equal -2. So what do we know about our numbers then? Well, 1 would have to be positive 1 negative? Nope, that wouldn't work because then it would multiply to be a positive 1. So they're going to have to both be negative. So it's going to be -1 and -1. So m minus 1 times m minus 1, or m minus 1 squared. Okay. Next one, we have d's in our factors. They have to multiply to be 25 and add to equal -10. So that means both numbers are negative. So -5 and -5. Or we could write that as d minus 5 squared. All right, last thing. We're going to take what we've been doing with factoring and apply it to solving equations. So first, if I want to solve this, I could like try subtracting some things and everything, but I'd still be left with this a squared in my equation. So we can actually solve these equations by factoring. So we're going to factor a squared plus 6a plus 9. So what multiplies to be 9 and adds to be 6? I have 1 and 9, and I have 3 and 3. So I'm going to have a plus 3 times a plus 3, or that would be a plus 3 squared, equals 0. And so I know if I take two numbers multiplied together and the answer is 0, that means one of those things has to be equal to 0. So if I set a plus 3 equal to 0, then I could subtract 3. So a would have to equal -3. Now you can write this out twice, but if you set both parts equal to 0, you're going to be getting the same answer both times. So it's kind of a waste of time. You can just do one. Okay, now I have this difference of squares here. I know it's a difference of squares because I'm subtracting. And n squared is n times n. And 81 is 9 times 9. So both of those are perfect square numbers. So this could be factored into, remember I'm finding factors of -81 that add to equal 0 because there's no number in the middle. So that would be -9 and +9. So we're going to have n minus 9 and n plus 9 when we factor this one equals 0. And remember, if I'm taking this times this and it equals 0, then either this part has to equal 0 or this part has to equal 0. So I'm going to set both of those equal to 0 and solve the equations. So I'm going to add 9 to both sides, so I get n equals 9. And subtract 9 on this side, so n equals -9. All right, be sure to answer the essential question and write your summary.